Okay, in this exercise we are asked to find the limit as x goes to 2 from the left of 3 plus the greatest integer function of argument 2x minus 4. Now, before we do this exercise, let's just have a word on the greatest integer function. The greatest integer function of a number x is going to be itself if x is an integer. For example, if x is equal to 3, then the greatest integer of 3 is going to be 3. The greatest integer of 0 is 0, and the greatest integer of minus, let's say, 2 will be the same, which is minus 2. Now, if x is not an integer, which means that x lies between an integer and the next one, then the greatest integer of that is going to be the very first integer to the left of x, which is in this case n. For example, if you want to calculate the greatest integer of 1.3, then we look at 1.3 here. We see that 1.3 is between 1 and 2, somewhere here. So this is 1.3. Now this, since 1.3 is not an integer, so you will pick up the very first integer to its left, which is equal to 1. Similarly, if you want to calculate the greatest integer of minus 0.01, let's say, then we look at minus 0.01. We see that it is between minus 1 and 0, quite close to 0 here. Alright, and since this is not an integer, we will pick up the very first integer to its left, although it is extremely close to 0, but the value of the greatest integer of minus 0.01 is going to be minus 1. Okay, having said that, now let's just look at the limit as x goes to 2 from the left of the greatest integer of 2x minus 4. Now, as x goes to 2 from the left, which means numbers such as 1.9999, okay, and if you multiply that by 2, so 2 times a very close number to 2 is going to be very close to 4, but from the left. So this is going to be 4 from the left minus exact 4. So we're talking about 3.999 numbers such as this. Minus 4. So this is going to be very close to 0, but it will always bear a negative sign, because now this is not 4, and minus 4, which is exact, is going to be always negative. Alright, now since this number is not an integer, it's really very close to 0, but it's from the left, which means it has a negative sign, then we will pick up the very first integer to its left. So this number is somewhere here, so the result is going to be minus 1. Now the total limit is going to be equal to, of course, 3 minus 1, which is equal to 2. So this is the limit as x goes to 2 from the left of 3 plus the greatest integer of 2, x minus 4, will be equal to 3 minus 1, because the limit of 3 is just 3, and the result is going to be equal to 2. And this is just a graph of the greatest integer of 2x minus 4. And as you can see that if you approach 2 from this side, from the left, then the function will sustain its value of minus 1 as you approach 2 from the left. Okay, in this exercise we're asked to find the limit as x goes to minus half of the greatest integer of 2x plus 3. Now, of course, we have to check the limit from the left and also from the right. Okay, we first check the limit as x approaches minus half from the left. Now, one should understand that if you come to minus half from the left, let's see that this is 1 now, and this is minus half, and minus half is here, and minus half in decimal notation is minus 0.5. Now, if you come to minus half from the left, so you are talking about numbers such as minus 0.500000001, very close to minus 0.5, but from the left. Okay, for easiness of treatment, let's just say that I'm looking at numbers such as minus 0.501. Now, if you multiply this number by 2, again, we are looking at this expression, 2x plus 3. If you multiply this number by 2, you will get minus 1.002, which is a number that is very, very close to minus 1, but again from the left. So we are coming to minus 1 from the left just by multiplying minus half by 2. So, and if you add 3 to that, so you will talk about numbers that are very close to 2, but again from the left, which means that it will be something like 1.998. So this is, of course, if you want to try some numerical values. In a lump sum, what we say is the following. See, there's 2x plus 3. As x goes to 1 half minus 1 half from the left, then this is going to go to minus 1 from the left. And if you add the 3 to that, that is going to be 2. The result is 2, but that will come into 2 from the left. So this is going to 2 from the left. Now the greatest integer of 2 from the left, again, this is if this is 1 and this is 2, and you come into 2 from this side, so this is not an integer. It's really very close to 2, but it's not 2. So we will pick up the very first integer to its left, and the answer to that is going to be 1. Okay, now let's look at the other limit, which is when x goes to minus half from the right. So again, if you go to minus half from the right, so you're talking about numbers such as minus 0.49999, etc. So for easiness again of calculations, I'm going to pick up a number such as minus 0.499. Now if you multiply that number by 2, we're looking at this expression again, 2x plus 3. Multiply that number by 2, you're going to get something very, very close to minus 1, but it will be minus 0.998. This is if you multiply this by 2, and if you add 3 to it, that is going to be very, very close to 2, but again from the right, so it's going to be 2.002. Okay, and the greatest integer of 2.0002, for example, any number that is close to 2 but from the right, since it is not an integer, then we will pick up the very first integer to its left, which is equal to 2. Okay, that then in a shortcut, we say that 2x plus 3, as x goes to minus half from the right, now this 2x is going to go to minus 1 from the right, and if you add 3 to it, now minus 1 and 3 is going to go to 2, but we are coming to that from the right, so this is a little bit more than 2, and the greatest integer of that is just 2. Now you can see that the limit as x goes to minus half from the left is not the same as the limit as x goes to minus 1 half from the right, and therefore the limit does not exist. Okay, this exercise goes around finding the limit as x approaches 1 of some combination of greatest integer functions. So we will look at the limit as x goes to 1 from the right, and also as x goes to 1 from the left. Let's just consider now the limit as x goes to 1 from the right and look at the arguments of the greatest integer functions. So the first argument, which is 1 minus x here, and now as x goes to 1 from the right, now 1 minus x is going to go to 1 minus 1 from the right, and that is going to be very, very close to 0, but it will bear a minus sign, right? Because it's exact 1 minus some number that is a little bit more than 1. And therefore the greatest integer of that 0, since it is from the left, yes, since it is not an integer, it will be the very first integer to its left. So this is 0 and this is minus 1, and the number is just here. So we will pick up the very first integer to its left, which is equal to minus 1. So therefore 1 minus x is going to go to minus 1. Now as x goes to 1 from the right, let's look at the other argument, which is x minus 1. So this is going to go to 1 from the right minus 1, so that is again very close to 0, but it will be 0 from the right because it is a little bit more than 1 minus exact 1. And the greatest integer of that, x minus 1, is going to be the very first integer to the left of that number, since it is not an integer, and that is exactly 0. So now this limit is going to be equal to minus 1 plus 0, and that is minus 1. Now let's look at the second limit. Now the argument of the first greatest integer function, 1 minus x, as x goes to 1 from the left, 1 minus x is going to go to 1 minus 1 from the left. So that is very close to 0, but it will bear a positive sign, because it is exact 1 minus a little bit less than 1 is going to be 0, and with a positive sign always. So the greatest integer, 1 minus x, is going to go to 0, because that's the very first integer to the left of a little bit of a number that is a little bit more than 0. Okay, now for the second argument, which is now as x goes to 1 from the left, now we're looking at the greatest integer of x minus 1. Now x minus 1 is going to go to 1 from the left minus 1, and that is going to go to 0, but it will bear a negative sign always, and of course the greatest integer of that is going to be minus 1. So this is x minus 1 is going to go to minus 1, and the result is going to be 0 minus 1 is equal to minus 1. So you can see the limit from the right is equal to the limit from the left, and the limit exists.